All right, welcome back everyone. Hope you had a good holiday. We get down to business today. So far, is everything in here going okay for everyone? Homework and everything is going all right? Can y'all open the door for him, please? All right, so we are going to pick up where we left off. We had talked about order of operations, right? And I asked you to just do the homework through that section. If there's a little time at the end of class, I might answer some questions over homework. Remember, if you need to, contact me. You know, if you have a question while you're doing homework at home. Text me, email me, call me if you need something. But now we're going to move on to the next part of this section, which is solving linear equations in one unknown variable. So before we begin this, let's just kind of discuss what we mean by a linear equation in one variable. So linear equations in one unknown. All right, so when you see this word unknown, you can also think of that as the word variable. So I'm going to put an equation up here. Right there. This is an example of a linear equation in one unknown. So let's just make sure we understand the wording and what we're looking at. First of all, it's an equation, right? So what makes it an equation is the fact that we see an equal sign in there, right? And anytime we see an equal sign, we are going to be thinking, well, that means we need to have a solution as an answer, like x equals 5 or x equals 1/2, something like that, right? So equations are going to produce solutions. So we have an equation, right? Now, what about the word linear? Where does that come into play here? Does anyone know why this is a linear equation? Okay, what about the x? Yeah, so this x is not squared or cubed or square rooted or anything. It's just x, so we can imagine it being like to the first power, all right? And when you have the variable to the first power, we call it linear. All right, so that's the part of this that makes it linear. Later on in this class, we will talk about equations where that's perhaps x squared, and then it's going to be what we call a quadratic, right? So linear equations have to have your variable raised to the first power, and then it's one variable, right? And that's because there's just one letter in here, right? So let me show you an example of a linear equation with two unknowns. That'd be something like this. Okay, equation, linear because that has a 1 on it, this has a 1 on it, right? Even though we don't write it. And there's two unknowns. So this is a completely different problem than this problem, right? So part of this is just recognition of what we're looking at before we actually go and try and do anything with it, all right? So we have a linear equation and one unknown, and what we want to do is try and figure out, right? We want to find x, which makes this equation true. So for example, if I were to say x is 2 here, right? Replace x with 2. Is that a true statement? No, it wouldn't, right? 3 times 2 would be, because this is multiplication, right? That'd be 6 plus 1 is not 5, right? So our goal, what we want to do is try and find the value of x that would make this true, right? So can you look at that and tell what it would be?
1.
Would 1 work? 3 times 1 would give you 3, right? Plus 1 would be 4, so that wouldn't work. So just visually, can you look at it and tell? I don't think it's obvious, no? That the answer is 4/3? That's not obvious. But we have a way of doing this, right? We have a systematic approach. If I gave you this equation, I think most of us could look at that and say, hey, that's a linear equation with one unknown, right? And you could probably just look at it, say, yeah, x is 1 would work, right? And you wouldn't even have to do any work. You just say, oh yeah, 1 + 1 is 2. But when you have an equation where you can't look at it and you don't have an obvious approach to it, like an obvious just plug in and get it to be true, then we need a systematic way of getting to the answer. So with linear equations, does anyone recall how it is we go about solving these? Get x by itself. That's the whole goal here. Okay, so to solve these, linear equations with one unknown, our goal, our ultimate goal, is to isolate x. In other words, solve for x. Now, what are the things you're allowed to do to get to this? Like, to isolate x, what things are legal in our algebra? What are we allowed to do? So when you have an equation, what are the things you've been told you can do with an equation? You can subtract something on both sides. You can add something on both sides. You can multiply both sides by something, and you can divide both sides by something, right? Those are the kind of the rules. So if we're going to try and isolate x, right, we're trying to get that by itself, where do we begin? Subtracting the 1. Okay, so what you're going to do is you look at this and you realize you have two terms here, right? Terms are separated by addition and subtraction. So we want to get first, to get the x, we want to get this term by itself first. So we want to get rid of that term, so we subtract 1 on both sides. Now I know a lot of y'all are looking at me like, I know this already. It's okay, don't worry, they'll get a little harder. All right, so we are going to go 3x plus 1 equals 5. And I'm going to use the vertical method for this. So when I subtract 1 on both sides, I'm going to say minus 1, minus 1. And why am I subtracting 1 and not adding 1?
To isolate that.
Yeah, because if I have 1 here, I want it to go away, right? I need to take 1 away, right? If I add 1, it'll become a 2. So subtract 1 on both sides. When these cancel out like that, what am I left with over here? 3x equals 5 minus 1 is 4, right? So now we are closer to having x by itself. The next step is to actually isolate the x from the 3. So how can you get rid of the 3 there? So why divide?
Because it's multiplied times the x.
Yeah, because it's being multiplied, right? This is 3 times x, so to undo the multiplication, we divide. So we'll divide both sides by 3. Divide by 3. Divide by 3. And what is 3 divided by 3? 1, right? So these reduce, and it's basically a 1, but we won't write 1. We'll just write x, and then equals 4/3. And that's your answer right there. X is isolated. So if you replace this right here with 4/3, we should get a true statement, right? And for this example, I'm going to check my work, but I'm not going to require you to check your work. All right? So, but I'm going to check it for this one. So to check it, I'm going to go 3. What if I replaced it with 4/3 there? Times 4 over 3 plus 1. Does that equal 5? Well, there's kind of different ways you can do this, right? We have to multiply those before we add. So I could just cancel these 3's. Because this 3 is really like a 3 over 1. So it's like in the numerator, and the other 3's in the denominator, so they cancel out. And that leaves me with what here? 4. And 4 plus 1 is 5. Check, right? So it works. Okay, so that's the method. Presented with a problem, we have to recognize that it's a linear equation in one variable. Once we recognize it, then we know that the procedure is to isolate x. The method you use for that is adding or subtracting things from both sides, isolating the term, and then multiplying or dividing to get it by itself. Yes? Okay, so let's try and do some that are a little more challenging than that. Leslie? Let's see here. Come on. All right, let's do that one. Okay, so let's look at number 16 there. So my first question to you is, is that a linear equation in one unknown? Does everyone agree that, come on, Robert. What happened here? It's about as good as I'm going to get right there. That is a linear equation, one unknown. You see an equal sign, right? You see x's in there. You only see one x, right? There's no y's in there or any other variables. So you have one unknown, you have an equation, and it's linear because the powers on the x are both 1. Okay, here we go. Let me get my little sticks. Okay, so let's see. I have these separated. So Vince, Victoria, did I call on y'all last time? I did not, right? These are the 3 that didn't get called. Everyone else did. So we'll start with Vince. Where's Vince at? All right, so what do you want to do first?
Multiply the 5 times x minus 2.
Okay, so 5 times x minus 2 equals 4x minus 10. So we're allowed to add and subtract things on both sides, multiply and divide by things on both sides. But before we do that, if we have parentheses, we have to remove those first. And to remove parentheses means we have to distribute. So you want me to multiply my 5 through the parentheses like that. Good. That'll be the first step. So what would you get if we distributed?
5x minus 10.
5x minus 10 equals?
4x minus 10.
Okay. All right, good. You want to keep going? Sure. Okay, so we have something different in this problem than we did in the first. And that is that we have x's on both sides of the equation, don't we? So when you have x's on both sides of the equation, you have the freedom at this point to decide which side of the equation you want to have your x's on. Like, you're either going to have them all on the left or you're going to have them all on the right. And it's your choice, all right? So you want to make a decision on how you want to go about this? Okay, what do you want to do?
Minus 4x on both sides.
Okay, so you've decided you don't want your x's on the right side, you're going to have them on the left side. So you're going to subtract 4x here, subtract 4x here. We're allowed to do that because it's an equation. You can subtract or add anything you want to both sides, but you have to do it on both sides. So let me do that step. Let's move on. Victoria? Where's Victoria? Hi. Okay, so what would we have when we do this, when we subtract the 4x? X minus 10
equals negative 10.
equals, these are gone, so negative 10. Okay? So now you have x's on one side, right? We want to keep our x here, so what would be the next step to get this x by itself?
Add 10.
Add 10 to both sides, right? We want to get rid of the minus 10, so we add 10 to both sides. So we'll add 10 here, add 10 here. What do you get there? So what's my left side?
Oh,
X, okay.
x equals 0.
And x is 0. Okay. Is that an answer? It's like x was 4/3 within the last problem. X is 0. That's an answer, right? So I said I'm not going to check these anymore, but maybe we can real quick. Let's just check real quick. If that were 0, what's 0 take away 2? Negative 2. What's 5 times negative 2? Negative 10, right? So this side would be negative 10 if I replace x with 0. What would we get over here if I replace x with 0?
0.
You get 0 minus 10, which is negative 10 again. So you get negative 10 equals negative 10. So it works. All right, let's go to the next one. Let's see. Milena? Milena, how you doing? Good? All right. Number 17. I'll write it down here. Is this a linear equation with one unknown? Yes. Okay, so what would you like to do first? Distribute the 3. All right, so I'm going to rewrite the left side. And when you distribute, what do you get? 6x minus 12. Right, everyone? I don't know if you've noticed this, but Do you see how when I do my math, I'm going like from line to line to line to line to line? I suggest that you do the same. I see a lot of students, they'll do like little scratch work on the side or try and do it all in their head. That might work for a problem like this, but as the problems get harder, you want some like more systematic approach. And when I'm grading your tests, if I can see line to line and see where you might make a mistake, you're going to get more partial credit than if you're trying to do it all in your head. All right? Okay, good. Now, you want to keep going? What do you want to do now? You got X's all over the place, right? Good. And that's the right word to use. You can combine these two together, and you can combine them because they're like terms. They both have X in them, right? So what would happen if you took 2 X's and take away 5 X's? What would you get? So you're taking 2 of them, taking away 5. So you should get negative 3 X's, right? Negative 3. And then on this side, we still have 6X minus 12. Yeah? Okay, we'll move on. Oh, this is the class that has all these weird... I'm going to mess this up. Hold on. Tiani.
Yes.
I got it right? Yeah, because I remember that it sounds more like an E. All right, Tiani.
Now I would add the 6x and the negative 3x.
So you want to get, you're going to choose to get this X out of here, right? So you said add, but you're trying to subtract. Okay, so you're going to, and this is your choice. You could have added 3x to both sides, but you're choosing to subtract 3x, or 6x and subtract 6x. All right, so these will go away. The right side will be negative 12. What's your left side?
It's going to be negative 9.
Negative 9 x's. Okay, good. You want to finish it off? How would you get this x by itself?
I would
Divide by negative 9. And you have to divide by the negative because negative divided by negative will give you the positive, right? So you get this. This becomes a 1. So you have x equals, and then over here, what's a negative divided by negative? Positive. So you know your answer is positive, right? It's positive 12 over 9. But you can reduce that fraction, right? There's a number that goes into both of these. That number is 3. So 3 goes into 12 4 times, and 3 goes into 9 3 times. So your answer is 4/3. Any questions?
Can we reduce that even more, or you want that, just that? You want
Well, is there a number that goes into both of these?
No.
No. So are you asking me, do I want it as a decimal?
Yeah.
Like 1.3?
Yeah.
I would leave it like this. If you put 1.333, then that's okay, I guess, you know. It's not wrong, but. All right, so far, y'all seem to be okay with this. The mistakes that I see on things, you know, like things like this, you know, students will say like this is negative 7x or positive 3x. Those are like little things, but they're important that we, you know, don't make those mistakes on tests. All right, let's see what those, let's see, these all look, 18 and 19 look pretty similar to what we just did, yeah? Just longer. Let's not go through these. Let's just talk through them. For this one right here, I would have to get rid of these parentheses, right? So what would I distribute through?
Positive.
A positive 1. Okay, so if you see plus and there's nothing here, then there's a 1 there. So this would just become 4 minus x. Then what about this one? I distribute what?
2.
Positive 2. Okay, and then you would be able to collect like terms together and then choose your side for x. This one, a little different. What would I distribute through here to get rid of the parentheses? Negative 1, right? And then over here, negative 1 again. Shall I move on? Move on? Okay, let's see. Oh, okay, there's one that looks a little bit different. All right, so let's take a look at this one right here. 3 parentheses t. We're using t instead of x. All right, over 2 equals t take away 6. So I'm not going to pull a stick here. I'm actually going to ask for a volunteer, someone who has not responded today, though. Any volunteers to help me do that one? Like how they would approach that? Go ahead.
Well, what I did first was I multiplied each side by 2
You'd multiply each side by 2? Why?
to get rid of the fraction and the remaining.
Okay, so this is the first time we've had a problem like this where we have a fraction, right? So what was your name?
Rodrigo?
Rodrigo. What Rodrigo's doing is correct. He is clearing fractions. So that is another kind of layer that we have with solving linear equations. We saw how we distributed through the parentheses. This is another thing we do. We clear the fractions. So you looked at the denominator. You said, hey, it would be nice if that 2 canceled, right? If it wasn't there. So you decided to multiply this side by 2 and that side by 2. So let me do that. I'm going to do it in a different color. So right now I'm clearing fractions. Multiplying by 2 here and multiplying this side by 2 also, right? But when I multiply this side by 2, because I have 2 terms here, I need to put that in parentheses so that my 2 will pass through to each term. Now what happens to the 2's on the left? They cancel. That was the whole point, right? The whole point was to make this and this go away. So what is left on the left-hand side?
3 parentheses t minus 7.
Okay, 3 times t minus 7. I forgot to ask if this was a linear equation and one unknown, but it is, right? Okay. 3 times t minus 7. And then over here, go ahead and distribute. What do you get there? 2t minus 12. So it's okay to distribute this way, right? It doesn't always have to be the front going through. It can be at the back and go through this way. We'll go ahead and distribute this one now also, like this. So we have 3t minus 21 equals 2t minus 12. All right, so take the next maybe minute and a half to see if you can come up with that answer. Then I'm going to pull a stick and we're going to see if they got it right. So get all your t's on one side, everything that's not t on the other side. See who our lucky contestant is going to be today. Okay, that's about a minute and a half, so it's not my fault. You get to pronounce it.
Elena Martinez.
All right, Elena, you're up.
Sorry.
Got that right? She's pronounced that right? Dang it. Okay. So did you get an answer? What did you get? 9? Okay, let's see. How many of you agree? Okay, good. So we don't need to go through it then. So if you did not get t equals 9, you need to put a little star next to that. And then after class, you need to just hang out for 30 seconds so I can figure out what happened. Yes?
Would you take points off if you ended the equation with another variable?
How do you mean?
So it starts off with t,
Uh-huh.
but then, I don't know.
Oh, like you just
if
switched it to
yeah,
x?
Yeah.
I mean, in this class, I would probably be okay with that. But it's kind of like, I mean, when you think about it, you're asked to solve for t, right? And then you tell me x is 2 or something. It just, It's like me asking you what your favorite color is and you tell me, I don't know, fish. Yeah. So, it's just, it doesn't, mathematically, it's not right. But I would be happy that you got the correct numerical answer. Yeah. Now, if you started the problem and you rewrote it and you replaced the t's with x's and then solved that and said x, then that would be okay. But if just like in the middle of the problem, you just like all of a sudden your x's became, or your t's became x's, that's a little different. All right. What about this next one, 21? Stephanie? Stephanie Cruz? Okay. So following the same thing we just did, right? It's a linear equation. There's one unknown. It's raised to the first power, but you have fractions. Okay? So don't let the fractions freak you out. What did we do on this one to get rid of the fractions?
You multiply
By 2, right? So over here, what do you think we should multiply by? 7, right? So the 7 should clear out the fractions because we have a 7 here and a 7 here. Agreed? Now, the way I'm going to write this, though, you have to be a little careful here. When you multiply the left side by 7, how many terms are on the left side? 2. That means you need a parenthesis, right? There's 2 terms. That means if you multiply this side by 7, it's going to have to distribute through when we do the multiplication. When we multiply this side by 7, do we have to do parentheses around this? No, because there's only one term, 13 over 7. So there is no distribution happening. Make sense?
Would it be wrong though if we go parentheses?
It would not be incorrect to do this, but you don't have multiple things to go to here. Like here, you have to have the parentheses because this has to go to both terms.
I just usually write it that way.
Yeah, this is fine. If you don't want to put the dot, you want to do parentheses, or if you want to put them both, it's correct still, written that way. All right, so Stephanie, on the right-hand side, let's start with the right-hand side. What's going to happen with these 7s? They're going to cancel, and that's why we did it, right? They're going to cancel, boom, boom, and you'll be left with 13 over here, right? Okay, now on the left-hand side, you have to distribute through, right? So here to here, and here to here. So let's do the second one. If we go here to here, you'll get your 7x, right? So we got 7x there. But in front of it, what happens when you multiply this times this? You get 42 over 7, which becomes 6. In other words, when the 7 goes to here, it's like a little 7 times that. These 7s cancel again, and you just get the 6, which again is why we did it, is so that the 7s would cancel. So you can look at that 2 ways. The 7s cancel, or it becomes 42 over 7, which is still 6. So what should be in front of this? 6, just the number 6 and then plus. Right? So this becomes 6, this is 7x, there's a plus between them, and that side's 13. And once we're here, this should be something that we're comfortable with, right, Josh?
Yep.
Okay, so what would you do here, Josh? Okay, so how would you do that?
Subtract 6.
Subtract 6 here, subtract 6 here, bam, bam, this is gone. Left side, 7x. Right side, what's that? 7? Oh, this is going to become a nice answer, isn't it? Final step, divide by 7, and you get 1. So I'm probably going to start showing a little less of the work here, like just assuming you know what to do from here to here. That okay? All right, let's keep going. See if these get any crazier. That one looks pretty similar. Well, let's look at number 23. I don't have enough time to go through all of these examples, so I have to kind of pick which ones I think are worth it. Okay, this one I think is different enough that we should talk about it. Kiana, that's right. See? Okay, Kiana, you have time to write that down yet? Okay. Linear equation, one unknown, yes? Equation, linear, one variable. Okay, so isolate the x. That's the whole name of the game here. You see fractions, yes? So you got to clear these fractions. In the previous two problems, the denominators we had were the same. Like in the first problem, there was only one denominator, 2, so we multiplied by 2. In the second problem we did, they both had 7s, right? So we multiplied by 7. Here, they're different denominators. So what do you multiply by in order to clear the fractions? Do you know? It's okay if you don't, and that's why we're here, right? So anyone want to help out? What would you multiply by? No? Yes?
So I did the last one a little bit different. I approached it like, fractions.
Yeah, you could do it that way.
Fraction.
Yep.
So I would do 2/5 minus 5/7 minus 1/1, and then I would multiply.
Okay, so you like brought that one over here? Is that what you're saying? Yeah?
Yeah, like minusing that,
Mm-hmm.
combining all of those.
Getting them all over here, and so you're choosing to do it by not clearing fractions, which is fine, and you can do it that way. The only issue I have with that is later on we are going to need to be comfortable clearing fractions. Like it's something we're going to need to be able to do. So I want us to get our practice with it here. All right, so let me try and help you with this. We need a 5 to cancel here, right? And we need a 7 to cancel here. So we need to multiply both sides by a number that has both a 5 in it and a 7. So what number has both 5 and 7 in it? 35. Do you all agree? The number 35? So what we do, we call that, if we look at 5 times 7, it's 35. We call this a LCM, or a least common multiple. So what we're doing is we're trying to figure out the smallest number we can possibly find that is a multiple of both of these numbers. And in this case, 35 is the smallest one. Yes?
So I guess I just made it more complicated then.
Well,
Because I was going to say multiply them all by 30, multiply them to get 35 in the denominator.
you were going to have to do that to get a common denominator, weren't you?
An extra step.
Yeah. And I think students make more mistakes trying to combine fractions together than they do multiplying through by an LCM. Because once you multiply both sides by 35, once we do that, there are no more fractions. And then life is good when there's not fractions. So we'll get to the same answer. We should, but. Okay, understand the 35? So let's just say, what if this was a 4, just for the sake of seeing if you understand. What if this was a 4 and an 8? What would I multiply by? I could do 32, right? 16, I could do 16. I could also do 8. Because 8 is a multiple of both 4 and 8, right? So you want to try and find the smallest one. Now, if you were to have done, if this were 4 and 8, if you were to do 32, it would still work, but your numbers would just get bigger. All right, here we go. Going to multiply through by 35 on both sides. So when I hit the left side here with 35, do I need a parentheses over here? I'm going to put 35 here. Do I need a parentheses? How many terms do you have? 2, so you have to have parentheses. So I'm going to multiply this side by 35. Okay, over here I'm going to multiply by 35 also. Do I need parentheses? How many terms do you have? 2 terms, right? You have to have parentheses. Do y'all see that that's 2 terms? Okay, so the 35 must go to each one, and then here the 35 must go to each one. All right. You ready? Here we go. So I'm going to do this first multiplication. And I want to just make sure everyone follows what's about to happen. When this 35 comes through here, I could make 35 times 2, couldn't I? I could do that. But I know the 35 and the 5 should cancel out. Like something should go away. So when the 35, I'm going to write it down. I'm doing 35 times 2x over 5 minus 35 times 5x over 7 equals 35x minus 35. See if that makes sense. 35, I'm going to multiply by the 2 and the x, right? And then here, 35, minus 35 times 5, and then the x, and then the 7. Do y'all see that? Does that make sense? Sure? Y'all give me this weird look. So why, the reason I didn't multiply these two together and give you 70 is because this is going to become what? 7. And I didn't multiply these together because this is going to become 5. All right, so it's like they kind of cancel as you go through. And it should. We should get these to become nice numbers. This will become 7 times 2x. I still had 2x there. Minus what? This becomes 5 times what's still here? 5x. Then equals 35x minus 35. Okay. Itzel? That's right. Why did I have such a hard time with this? Y'all are making me feel terrible. Okay, Itzel, are you following up to this point? Okay, so next line. What should my next line read? Multiply, right? So we're going to multiply. So this will become, I'll do 14x. I'll do it over here. 14x. Then minus what? 25x. And then we can just rewrite the other side, right? Can I combine these together? I can, right? Because they're both like terms. They both have x. So what would you get if you had 14 x's and then you take away 25 x's? You get negative, how many? Negative 11. Negative 11 x's. So, I mean, if you are having trouble with that part right there, you just need to come talk with me or go to the tutoring lab. Make sure that you understand that, because that, combining like terms is something that I'm assuming you can do. Like arithmetic, this is like kind of like arithmetic, all right? But students have trouble with it, so make sure you get help on that if you're struggling. All right? Itzel, we'll stick with you here. You're okay up to that point? Okay, now what? Yeah, what would you do? You want to add 11x? I'm glad you did that, okay? Because that's different than I think what a lot of people would do, but I want to see it happen, all right? So you're going to add 11x here and add 11x here. Okay, let's do it. Is that legal, what she's doing? Yes? Add 11x, add 11x. That? Okay, okay. So what does the left side of the equation become now? 0, right? Because there's nothing left over there. So we have 0 equals, now 35x's, we added 11x's, that's going to be 46x's, and we still have minus 35. All right, so you kind of got us here, so you want to keep going? Isolate the x, you can do it. Isolate the x, try and get this by itself. So do you want this here anymore? No. Okay, how do you get rid of this then? Add it, right? Add 35 to both sides. Okay, so add 35 here, add 35 here. The left side becomes 35, right? Nothing plus 35 is 35, and the right side is 46x. We're almost there. What would be our last step? Divide both sides by 46, and we're done. Unless we can reduce, but I don't think this reduces. So our final answer is 35 over 46 equals x. Whew. Okay. So maybe just combining the fractions in the beginning would have been easier. I mean, faster. That really depends on you. I mean, like how long this would take. Depends on your comfort level with this. So back here, right at this step right here, okay? You wanted to add 11x, and we got the answer, right? Okay, so I think a lot of students, what they would have done is they would have said, look, we have x's by themselves here. We just need to get this x out of here. So what if we subtract 35x here? subtract 35x here. This would become negative 35 on this side, agreed? Then over here, what would we get? Negative 11, take away 35, negative 46x. And now you would divide both sides by negative 46. And if you divide this by negative 46, divide that by negative 46, gone. You have x there, and here a negative over negative is positive, so you get the same answer, right? Okay, so maybe that's a little faster, but they both get you to the same place. And that is one of the good things about math, is that as long as you don't break any rules, as long as you follow the correct procedures, like we should all get to the same place, right? We should not get different answers doing it different ways. If that were the case, then this would be more like an English class, right? Y'all know what I'm saying? Right? I remember, being a math major in college. I can remember I had to take the basic classes. I had to write some English papers, right? I had to write some papers, read some books, and I hated it. I wrote a paper on lions. I'll never forget it. It was one of my first big college papers, like probably a 20-page paper. I went and visited the zoo. I met this lion at the zoo. His name was Assad. I fed him. Okay, he scared me, roared, jumped up on the cage. I studied all these different things about lions, wrote this 20-page paper. I thought it was the best thing ever. I turned it in and I got like a D. And there was no grammatical errors. It was just what I said in the paper. They didn't really care for it. And so since then, it's subjective, right? Math isn't subjective. We should all get the same answer. If you follow the rules, we get to the same place. There's no gray area, right? Okay. Distribute. We're okay with that, you think? How about 25? Do you want me to go through it, or? Yeah, 25 looks pretty weird. I agree. I think 25 is worth us looking at. All right. Damien. The one I feel comfortable with here. Not here. All right, so Damien is out. Evan, I can do Evan. All right? Or is it Yvonne? Okay. All right. Evan, have you been following along okay? Everything's okay today? All right, is this a linear equation with one unknown? Yep, equation. Linear, x, right? One unknown. All right, so you see fractions. You want to try and clear the fractions? What number would you multiply by to clear the fractions? 3, right? So this one is it's not like the previous one where you had to come up with 35. There's only one denominator. The trouble with this one is like the actual distribution of the 3 through things, because this just looks weird. So I'm just going to go to the next step. I'm going to rewrite this. I'm going to rewrite it before I actually distribute the 3. Okay, so here comes my 3. I'm going to multiply this side by 3, and everything over here has to go in parentheses, okay? And then over here, I'm going to multiply this side by 3. And this is where things are weird. Do I need a parentheses around this? I actually don't need it, but if I write it, it's not wrong. But well, let's deal with that when we get to it, okay? Well, let's do that side, but let's deal with this when we get to it. Are y'all okay with that so far? All right. Yes?
I was wondering why you divided by 3.
Why I'm multiplying by 3?
Yeah, multiplying.
Because the whole idea is to try and get this 3 to cancel with something, right? So I would like to have a 3 on top so that the 3 cancels, right? So I need to introduce the 3 on top. This is how I introduce the 3 on top. Remember, this 3 is really like a 3 over 1. So when I multiply it through, that 3 is going to wind up on top of that one, and then it'll cancel, right? Okay. All right, so let's see how this is going to distribute. Here to here, yeah? That's just 12. We're good? Okay. 12. All right, now this is the part where students get in trouble. This 3 has to go through. Is it going to go to the 1/3 and get distributed through here, or does it just go to one of them? And why? Right? So you're saying it's just going to go to one of them? So why not both?
Because that other set is inside the parentheses, which is going to be multiplied from what we just multiplied the 3 to. So
This is hard, right? It's
Yeah.
hard to explain this, so that's what I'm trying to get at here. So let me make you think about something else. Okay, let's say I had two numbers being multiplied, 3 times 4. Okay, what is that? 12, right? Okay, what if I told you to come in here now and multiply it by 2? Take this answer and multiply it by 2. So I want you to multiply this by 2. What would your answer be?
24.
Be 24, right? It'd be 12 times 2, which is 24. So the way you're doing that is you're saying, look, this is 12, right? And then you're hitting that with the 2 and it becomes 24. Another way you could do that is to do this to this. What's this to this? 6, and then that answer times what? 4, that's 24, right? What would not work is if you distributed the 2 to both. What's this times this? 6 times what's this times this? 8. What's 6 times 8? It's not 24, right? We don't distribute a number if we have multiplication here. It doesn't distribute to both. It only goes to one of them. Does that make sense? So here, when I'm multiplying this 3 over to these, this is kind of like the 3 and the 4 are over there. It's two things being multiplied, right? So this 3 is only going to impact one of those. It's one or the other, but not both. I want it to impact this one because that's going to cancel the 3. Does that help at all? Or does that just make it more confusing? Okay, so if you have multiplication here between two things, the 3 will only impact that one. So what is the 3 divided by the 3? What's going to happen? It's going to cancel out and become a 1, right? So I'll have the minus sign here. The 3's cancel, and all I'm left with is the 2 minus 7x. Nothing gets changed on that one. It stays the same. I still need the minus sign, and I still have to put these in parentheses. Okay? Now, with that same idea in mind, Rodrigo, we called on you already. So this was Devin, and I thought it was Dwayne or something last time, but I got it now. That's a V. Okay, Devin, on this side, this 3 has to go through here. You have multiplication right there between these two things. So that 3 is going to impact, am I going to hit this and this, or am I going to only hit one of them? Just one. So which one would be easier to do? 2, right? So let's just pass the 3 to the 2, and that becomes a 6. 3 times 2 is 6, and then you still need this in parentheses, x minus 1. Okay. I think at this point we should be at a more comfortable place, right? So do you want to keep going, Devin?
So I would do the parentheses on
Uh-huh.
the side first, so it'll be -2.
Yeah, so this can go through. So let me continue that over here. So 12, you said it's going to be -2, and then what?
And +7.
Plus 7x, good. And let's move to the other side.
Maybe 6x.
6x
-6.
minus 6. Okay, so distributing the 6 through. Good, we're there. Now we start going through the whole thing of isolating, right? Collecting like things together, isolating. On the left side, can I do anything before I move things around? Can I do anything over here?
12 minus 2.
Yeah, 12 minus 2 is 10. So I can go 10 plus 7x equals 6x minus 6. And which side do y'all want the x's on? On the left side or the right side? You want to go left? We'll stick with Devin. You want to go left? So if I want to keep my x's over here, what am I going to do?
You have to do, subtract the 10, and then that would go.
Okay, so you want to get that. Oh, so you're going to do it all at one time. That's fine. So you want to take away this 6x here, take away this 6x here. That'll get rid of your x's over here. And you're kind of looking ahead and saying, I also am going to need that 10 to be gone. So you're going to do this all at the same time. Okay. Okay, so simultaneously getting the x's to go away here and getting that 10 to go away on that side. I like this. Okay, as we progress, we want to be able to do like more than one step at a time. All right, so what would we be left with here at the end of the day? This is just x or 1x. And it's not wrong to write 1x, okay? That wouldn't be counted wrong. And then this side is negative 16. So we're done. We have our answer. X is negative 16. I think the clearing of the fractions here is a little tricky. Would you all agree?
Yeah.
All right. Can I just show you just a slightly different approach? I mean, not to confuse you, but just if you really hate this, what I just did, here's a different approach. Just watch what I do, all right? 4 minus 2/3 plus 7/3 x equals 2x minus 2. Can you tell me what I did there?
Multiply the 1/3 by into parentheses.
Yeah, so I didn't clear fractions first. What I did is I distributed the negative 1/3 through here and here. So I multiply negative 1/3 times 2, I get negative 2/3. I multiply negative 1/3 times negative 7x, I get a positive 7/3 x. Do you all see that? And then this side I distributed the 2 through. Now, if I come in here and I clear the fractions, I'll multiply this side by 3, this side by 3, right? And now when I do this, it's a little bit cleaner to see it. Do y'all agree? So remember I said there's more than one way to do this. We should all get the same answer. That's a different approach. So I always say math, these problems is always, you're trying to get from point A to point B, right? Trying to get from the problem to the answer. And if you're really good at math and you've done enough of it, then this path from A to B can be relatively short because you do it all very efficiently. If you're not as comfortable, then your path may be a little bit longer. If you're really struggling, then you might, go off, wander around for a while, and hopefully get here. But if you break a rule, if you do something you're not allowed to do, then you no longer are on a path, like you've gone off the map, so to speak. And the only way to get to B is to make a mistake and get yourself somehow back. All right, so to me, my experience in this, I know that to do that, this would probably be a little faster, but yeah, okay. See if there's anything else that we want to go over here with these linear equations. I think those are good. Yeah, I think those are all similar enough that you could handle those. So that completes that section. You should be able to finish the homework for order of operations and solving linear equations. Yes?
I didn't know how to do 9 through 15 on the homework.
9 through 15. This right here?
Yeah.
These? Okay, so I can't do all of them, but I'll let you choose maybe 1 or 2 of them. Are we looking at the same thing? Is this what you're talking about? Yeah. You pick.
12.
12? Okay.
Actually, no, 15.
15? All right. So 15 has been requested here.
This is on what page of our homework?
What page is this? It's 11? Yeah, that looks pretty bad. Yeah, that looks pretty bad. Okay, so this section is about order of operations. So our order of operations is parentheses exponents, right? Please excuse my dear Aunt Sally. Parentheses exponents, multiplication, division from left to right, right? Addition, subtraction from left to right. So first thing you see is parentheses, right? So I'm going to just, on the side here, this is scratch work, okay? I'm going to put SW, scratch work. Doing this on the side. What is 1/4 take away 2/3? So when we do this, we have 2 fractions, they have different denominators, and we're subtracting them, right? Which means we need a common denominator. I showed you how to do that. I also showed you a shortcut where you could go like that, and like that, and like that. Okay? So either way, I would expect that you could get to negative 5/12 here. Okay, so I'm just going to assume you can do that. Is that all right? Okay, so now I'm going to come back to the problem. My next line is going to read this. Negative 5/12 squared over 2 cubed plus 1/2 divided by 3/8. So all I've done is replace that with what I found, right? Okay, what should I do next? Exponents, right? Come next. So I actually need to take this fraction and square it, right? And while I'm at it, I'm going to take the 2 and I'm going to cube it. So over here, scratch work, when I do negative 5/12 squared, that's actually square the top and bottom, right? Or just multiply that fraction times itself. So let me write it this way. You're going to do this times itself. Okay, so how do we multiply fractions? Straight across. Negative times negative is positive, so we get 25 on top, the bottom 144. Yes? Okay. And then on the bottom we have 2 cubed. 2 cubed is what? 8. Okay, so here's where we are. We are at 25 over 144 over 8 plus 1/2 divided by 3/8. We good up to that point? All right, next order of operation, multiplication, division from left to right. Yes? So we have division over here, don't we? This one is a little tricky, and I did talk about this in class. I don't remember exactly the example I gave you, but I think I did write something to the effect of this. Like if I write a fraction like this is bad notation. Do you remember me talking about one of these bars has to be bigger than the other? No? You don't? No? You don't? Did I? I'm seeing more no's than yeses. Okay, then maybe I should make sure you understand this. All right. So look, let's look at this. If I have 1/2 and I tell you divide by 3/4, this means that you're going to take 1/2 and multiply by what? 4 over 3. So this really means 1/2 divided by 3/4. And how do we do division of two fractions? You flip and multiply, right? So when we see a fraction over a fraction, you can write it this way, and then we flip, and it becomes that. Everyone comfortable with that? Sure? Okay, so compare that to, let me do it up here. What would 5 over 3/4 become? So here's where you have a problem, because do I mean take the number 5 and divide it by 3/4? Or do I mean take the number 5/3 and divide it by 4? So do I mean this? Or do I mean this? Do y'all see the difference between these two?
Yes.
So which one is this? You can't tell, okay? So it's a trick question. In order for me to be able to distinguish which of these two it is, I have to make one of these bars longer. So if I make that bar longer, which one are we talking about, the top one or the bottom? We're talking about the top one, okay? So if this bar is long, we're talking about this one, all right? This one, I would have to write it like this, 5/3 big bar over 4. See the difference between those? So when you look at this problem right here, 25 over 144 over 8, the big bar is this bar right here, this division bar. So this really means 25 over 144 divided by 8, right? So I'm going to write that over here. This is 25 over 144 divided by 8. That's the same as 25 over 144 divided by 8 over 1. Why am I writing the 8 as a fraction?